Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be dealing with problem solving of questions based on question 8 and 9, which is electrochemistry, under the knowledge area chemical change. So we'll be focusing on problem solving strategies. How do you break down the exam questions and how do you answer questions? So if you can check, these are our objectives. We'll look at the entire electrochemical cells. Remember, in grade 12, we do two electrochemical cells, which is our galvanic cell, or you can call it voltaic cell, and we have our electrolytic cell. So the galvanic cell, we are saying, is a spontaneous process, which is exothermic because energy is given off. And then you have your electrolytic cell, which is a non-spontaneous reactions. And then we are saying this is endothermic because we have electrical energy being converted to chemical energy. We're going to look at key similarities and differences between galvanic and electrolytic cell. Learners do confuse the two, and by so doing, they end up losing the marks. So we're going to make sure that you have a clear understanding and difference. You can know the difference between the two. And then, as I indicated, we're going to focus on the exam question, how to break down the question, and then the strategies on how to respond to those questions. So we are all about exam in terms of these questions. Don't forget, we are saying this is electrochemical cells, and these cells, they are devices that interconvert chemical energy and electrical energy. So you know by now that galvanic cell it converts chemical energy to electrical energy, and your electrolytic cell converts electrical energy to chemical energy. So you can see the other one, galvanic, we said is spontaneous and exothermic. Electrolytic, we said is non-spontaneous and endothermic. So we'll be looking at that, and then I hope this will help you as you go through these type of questions. Now, as we do, we'll look at questions, which by now we know that you have done these questions. You will be able to respond to questions based on them. Let's look at this one. It says the cell notation of a galvanic cell. So you are told that this galvanic cell is given as. So now, a few things to remember is to say, when you talk about cell notation, we are saying A, B, C, which means that the A is for the anode. We always start with the anode, and then the B is for the salt bridge, the C is for the cathode. At all times, cell notation, anode first, and then salt bridge, then cathode. And we are saying, always know that we are starting with a solid, we end as well with the solid. So always in our cell notation, we'll have our conductors outside, which is our electrodes. Remember, these electrodes must be solid so that they can conduct electricity. So we're having, in this case, if you utilize cell notation well, you will see that from the anode side, you are given now the reactants and the product, which means we are starting with nickel on the anode. Nickel is forming nickel 2+. Hence, you are given nickel solid forming nickel 2+ aqueous solution. And I like it when you indicate the condition, the standard conditions there, to say this is under standard concentration, which is our initial concentration of 1 mole per cubic decimeter, and a temperature of 25 degrees Celsius or 298 kelvins. So already you can see that those are the conditions that are needed for these cells to work, to function. Now we are saying nickel is forming nickel plus 2 electrons. This is the reaction at the anode. And remember, at the anode, we said the reaction is called oxidation, which is loss of electrons. We said loss of electron is oxidation, which is the reducing agent, which means nickel is our reducing agent. So now the information you are collecting now, just by looking at this question, is to say we are starting with the anode, and on the anode side, we are always starting with the reducing agent. So we know that anode, we have a reducing agent. Our reducing agent is nickel. And then That is loss of electron, oxidation. Our reducing agent is nickel, which is solid, and then that nickel is oxidized. You can see that nickel oxidized means its oxidation number increases. You can see we're starting with nickel as 0, but nickel now is 2. So you can see that, okay, that's what happens at the anode. Now let's move now to the cathode, and we're saying when we go to the cathode, we are passing through the salt bridge there. We have the salt bridge. Remember the functions of the salt bridge. The first function is to complete the circuit, and the second one is to maintain electrical neutrality through the movement of ions. So you can see that we are having what we call external and internal circuit, because in our external circuit we have the electrons which are moving from the nickel half cell to the silver half cell. So the electrons will always move from the anode to the cathode. So you are able to see that that is our external circuit. And where we have the salt bridge, that is our internal circuit. What is moving in the salt bridge? The ions are moving in the salt bridge. So you are able to see that we have ions that are maintaining electrical neutrality, and those ions, we are saying they complete the circuit and they move through the salt bridge. So we have the salt bridge, we have the external circuit where the electrons will be lost from the anode to the cathode, which means now by looking at this cell notation, we're able to look at the entire topic to say this is what is really happening. Now, when it comes to this question, after we've analyzed the question, we are saying a bulb connected across the two electrodes. So there's a bulb connected there. We have a bulb connected. And then they're saying initially this bulb will glow brightly, so it will be bright. After some time, the brightness of the bulb decreases. Oh yes, what is happening? What makes the bulb, the brightness now to start to decrease? Remember, the first condition was the initial concentration was 1 mole per cubic decimeter. So definitely, as the electrons move this side, we're having now on the cathode side. Let's look at the reaction that is taking place on the cathode side. On the cathode side, we're starting with Ag+, which means our reaction starts with Ag+, which is our silver ions. So Ag+ will gain the electron to form Ag. So you can see now that it means now as the electrons move from the reducing agent to this side of the strongest oxidizing agent, which is Ag+, will gain those electrons to form Ag. So the electrons are moving in that direction, which is the 2 electrons. So meaning that we have to balance the electrons there so that all of them, they have 2 electrons involved. So you can be able to see that as nickel is losing the electrons, it's not Ag. Ag is solid. It doesn't have the ability to gain electrons. But Ag+, because it shows that it's electron deficient or it has lost electrons. That's why it's saving that positive. It shows that it has a shortage of electrons. So you can see that it is Ag+ that gains the electrons, not Ag, but Ag+. The product ions are the ones that are gaining the electrons to form Ag. So you can see that as nickel loses electrons, the concentration of Ni2+ increases. So you can see that, okay, what is going to happen here? We have increase in concentration of Ni2+. On the anode side, we're saying the concentration of the electrolyte, which in this case is Ni2+. That is our electrolyte. The concentration of the electrolyte increases on the anode side. But as the electrons moves to the cathode side, they are not coming to react with silver solid. They are reacting with silver ions. And the concentration of this Ag+, our electrolyte this side, it will definitely decrease. What does that mean? It means that when we start, the concentration of Ag+ or of the electrolyte on the cathode as well, it was 1 mole per cubic decimeter. And now, because this now Ag+ is reacting with the electrons from the anode, definitely the concentration of the Ag+ will decrease. Hence, meaning that as the concentration of the Ag+ decreases, it means that now our EMF as well will decrease. Hence, we are saying as long as Ag+ decreases, definitely our brightness is going to decrease. So you can see that our answer there is that the concentration of Ag plus decreases. The concentration, what makes the concentration of Ag plus to decreases is the electrons which are coming from the anode to the cathode. When they come through the cathode, they now react with Ag plus to form Ag. So we're expecting that the Ag solid will increase in mass because Ag is being formed. Ag is being formed. When Ag plus gain electrons, it forms Ag. So there will be increase in mass in terms of this one. And then definitely this side we said the concentration of Ni2 plus increases, but nickel is losing electrons. So definitely the solid one, nickel, will decrease in mass. So you are able to see that on the anode side, we have decrease in mass and increase in concentration of the electrolyte. On the cathode side, we have decrease in the concentration of the product ion or the electrolyte, but we have increase in the mass of our silver, which is our cathode in this case. So you are able to see that is that, and then you are able to get your 2 marks. I hope all the time when now you see the cell notation, you have a lot of information because you have the oxidation of reaction, reduction of reaction. You can even write the overall cell reaction from here to say we are starting our reaction with nickel and Ag plus. These are our reactants, nickel and Ag plus, the first 2 there from the cell notation. Those are our reactants. And if we check, you have nickel plus 2Ag plus forming nickel 2 plus 2Ag. So you are able to see that now our overall reaction now indicates that our reactants are these 2. And because you have done rates of reactions, you know that when we decrease the concentration of the reactants, we decrease the rate of reaction. Definitely. Hence, we are saying as the concentration of Ag plus decreases, the EMF will decrease as well. And then as we increase the concentration of Ag plus, the EMF will increase as well. I hope this will help you even when we deal with other different questions. Now let's look at our 1.2, which is focusing on which one of the half reactions below will be the main reaction at the cathode. The main reaction at the cathode. Now, the other strategy that you must have is to be able to see whether the process is electrolysis or galvanic cell. For example, this question, you can look at it and be able to say this is electrolysis, concentrated sodium chloride. So this must be electrolysis. And they're saying the reaction at the cathode. And then we're given that first reaction, second reaction of sodium plus, the one of water, and the one of another water, number D there. So the question is saying which reaction, main reaction, takes place at the cathode. Remember, when it comes to electrolysis, we are saying as long as we have in our electrolyte this chlorine during electrolysis or during decomposition of this concentrated sodium chloride, we are saying as long as you have chloride, chlorine will always be formed at the anode. So we know that this reaction, chlorine gas, is always at the anode. So this is the reaction at the anode. We have 2Cl minus forming chlorine gas. But now at the cathode, we have 2 options. It's either we'll get a reaction of sodium plus, you can see we have sodium there. So it's either sodium plus or water that will gain the electrons. And then the main explanation we're giving, we're saying it's not sodium plus that gains electrons. It is water that gains electrons. Why water? Water is a stronger oxidizing agent. So if we go to table 4b, you are able to see that water is a stronger oxidizing agent than sodium plus. Henceforth, water is the one that will gain electrons. And then our reaction is C, and then you are able to see that. Be careful that when we're not talking about we don't have this oxygen 4H plus and 4A minus. The reaction we're referring to is the water that forms hydrogen gas and hydroxide ion. So always be careful not to confuse the 2C and D there. So it is 2 waters plus 2 electrons that forms H2 plus 2OH minus. Then you are able to get your 2 marks. I hope that helps you as we prepare for what is coming. Now, let's look at this question. A spoon is plated with silver Ag during the process of electrolysis. So this is what we call electroplating. And then they are saying which of the following graphs best represent the concentration of silver ions, silver plus silver ions in the electrolyte over time. So now what you have to understand is that during electroplating and during purification of metals, like your purification of copper, we can say purification or we can say refining. During these processes, we are saying that the metal, we have the metal here and we have the object. Our object is the spoon. The object is the spoon. And then we are having our metal. In this case, our metal is silver. So now what is happening is that on the spoon side, we are saying that the spoon will always be on the cathode side. Say, how do we know that? Remember we said positive is anode, negative is cathode. Don't panic there. And then we are saying, okay, this is positive, so this is our anode. This is negative, small one, negative, bigger one, positive. And then we are saying this is cathode. So you are able to see there. To say, okay, we have our anode, and at the anode direction is called oxidation, and ox. Remember those mnemonics we're using, and ox, to say oxidation takes place at the anode. Red cat, reduction takes place at the cathode. So you are able to see that during this process, it is the metal that is involved in the reaction. If you go to your table, either table 4a or table 4b, you will find the reaction written as Ag plus an electron with double arrows to form Ag. What am I saying? I'm saying when you reverse that reaction, that is the reaction in the anode. When you write the reaction going forward, that is the reaction at the cathode. So already you have the memo there to say, okay, at the anode, Ag will lose electrons. We reverse the reaction at the anode. Ag will lose electrons to form Ag plus an electron. At the cathode, we just write the reverse of that, which is the forward reaction, which in this case is Ag plus an electron forming Ag. So you are able to see there that if the question was about the anode, this is the reaction you're going to write. But this question was about the cathode, to say, okay, at the cathode, that is the reaction. Now, what I want you to see this and appreciate here, to say it is Ag that forms Ag plus. That Ag plus definitely will join the electrolyte. Remember, our electrolyte always will have Ag plus there. It can be silver nitrate as the electrolyte. Now, the Ag plus was supposed to increase, but the very same Ag plus gains the electrons at the cathode and form Ag. So you see now, the concentration of the electrolyte is remaining the same because it is Ag, silver, the metal, that is providing the ions that are gained at the cathode side. So you can see that we are saying here the rate of oxidation is equals to, write it in full, to the rate of reduction. So the rate of oxidation is equal to the rate of reduction. So you are able to write that, and then you get your mark. So what are we saying? We're saying the concentration of the electrolyte remains the same. Why? Because the rate at which Ag is forming Ag plus and the rate at which Ag plus is gaining electrons, they are equal. The rate of oxidation is equal to the rate of reduction. Definitely the graph that shows constant concentration of the electrolyte is B. So you are choosing B because the concentration of the electrolyte will remain the same. Why? Because the rate of oxidation is equal to the rate of reduction. And these are exam questions that we are expecting you to have them. So I hope these type of activities, they helped you. Always, I'm starting by showing you this slide to say definitions. I know that by now you know all these definitions. You must be singing them. But it's my duty to always remind you to say oxidation, we said is loss of electron. Loss of electron is oxidation. Reduction is gaining of electrons. Gaining of electrons is reduction. That's what we do. And then we are saying on this loss of electrons, we will get our reducing agent. What is a reducing agent? It's a substance. It's a substance that loses electron or the substance that undergoes oxidation. And this substance will be oxidized. So that Leo Rao is able to remind you all this information. Gaining of electrons, we said, is reduction, and then we get our oxidizing agent. And we are saying this oxidizing agent is a substance. It's a substance that gains electrons, a substance that gains electrons, or the substance that undergoes reduction, or the substance that is reduced. So you are able to see that Leo Rao and Kero, they are able to help you to remember at all times all these nice definitions. And then at the anode, we said this is the electrode. Anode, we said, is the electrode where oxidation occur or take place. And then cathode is the electrode, red cat, is the electrode where reduction occurs. What is a reducing agent? Already we said it's a substance that undergoes oxidation. What is an oxidizing agent? It's a substance that undergoes reduction or a substance that gains electrons. So all those equations, the issue of oxidation numbers, always remind yourself. And then we have all that processes as the pre-knowledge that you had when you came to grade 12. Now, what are the similarities between galvanic cell and electrolytic cell? What are the things that they are the same for both processes? Because you got to understand these topics in such a way that you are able to know that these type of reactions will take place in both of them. Let's look at the reactions first. To say, in terms of redox reactions, we are saying both of them, they involve loss of electron, which is oxidation, and both of them, they involve gain of electrons, which is reduction. And they were saying loss of electron, which is oxidation, takes place at the anode. Gaining of electrons, which is reduction, takes place at the cathode. In both galvanic cells and electrolytic cell, we are expecting all of them at the anode, there will be loss of electrons, and then on the cathode, there will be gaining of electrons. Now, when it comes to electron flow as well, how are the electrons flowing? Are they flowing the same direction in the anode and the cathode? We are saying electrons always flow from anode, from A to C. You know ABC. So it's not from C to A. It's from anode to cathode all the time. The electrons will be lost at the anode. They will be gained at the cathode. So we're saying electrons are always from A to C for both galvanic and electrolytic cell. Now, the last part that we want to look at in terms of the similarities is the use of the electrolyte. I think by now you know what an electrolyte is. Remember, our electrodes, we always immerse them inside the electrolyte. Now, this electrolyte, remember we said, is the substance of which its aqueous solution contains ions. You remember we're talking about the ions when we talk about the salt bridge there, to say through that movement of ions we are able to maintain neutrality. So the electrolyte is very much important for this. And we are saying both electrolytic cell and galvanic cell, they both require an electrolyte. So we have electrolyte in galvanic cell, we have electrolyte in electrolytic cell. And we are saying this electrolyte is a substance of which the aqueous solution contains ions. Remember, we said when you take a salt, you put it inside water, it will definitely, that salt will ionize, it will form ions, and that is our electrolyte. You have done hydrolysis, which we said is the reaction of salt with water. I think you are able now to link acids and bases and this topic as well when you look at the electrolytes. And we have common electrolytes that we use that are very much common. For example, we saw during electroplating there, we're using silver nitrate. And then you got to know that for silver nitrate, in grade 10, you have done those ions, the positive ions and the negative ions, to say it is Ag plus and NO3 plus. We are dealing mostly with copper chloride, which is now your Cu2 plus and 2Cl minus. So you got to always know the types of electrolyte that we use and have activity. Understand when you see copper sulfate, you are able to see that it's a copper 2 plus and SO4 2 minus. And you can see that those like here where you have SO4 2 minus, which in this case it won't be playing a positive a role in terms of that. So you just have to understand that when I see copper sulfate, I'm seeing copper 2 plus. When I see copper chloride, I'm seeing copper 2 plus and 2Cl minus. So these are common electrolytes that we use, and then you are able to see them when you see questions like the question of sodium chloride. You know that is sodium plus and chlorine minus. But don't forget, we have water as well there. Hence, when we're dealing with the electrolysis of sodium chloride, we said on the anode, chlorine will form chloride ions will form chlorine gas. And the chlorine gas, when they lose electron, the chlorine gas, the electrons won't be gained by sodium plus. They will be gained by water, because water is a stronger oxidizing agent than sodium plus. So you can see now we are revising both topics, and you are beginning now to appreciate the difference and the similarities between these topics. Now, in terms of differences, look at energy conversion, for example. To say galvanic cell, it's a cell that converts chemical energy to electrical energy. Don't just write chemical to energy. You must say chemical to electrical energy. Chemical energy to electrical energy. Then you are able to get your marks. When it comes to electrolytic cell, is electrical energy to chemical energy. So I always say to learners, if you are forgetting, think about this. Electrical already. Electrical, we must start with electrical to chemical when it comes to electrolytic cell. Now, spontaneity, to say this galvanic cell, it is a spontaneous reaction. I want to talk to that one first, and then I will come and talk to electrolytic cell being a non-spontaneous reaction. What is the meaning of that? We are simply saying under galvanic cell, the reaction is always between strong oxidizing agent and strong reducing agent. So because all of them, they are strong, so the reaction is just a spontaneous reaction. No energy is added, because we are having very strong reducing agent and a strong oxidizing agent reacting together. So your reactants are always a strong oxidizing agent and your strong reducing agent, forming the weaker ones. But when it comes to the non-spontaneous cell, which is electrolytic cell, you will see that you have a weak oxidizing agent reacting with a weak reducing agent. Hence, because their strength is not that much, you need electricity to force the reaction to occur. Hence, this reaction was saying is non-spontaneous, because it won't take place on its own, because the strength of the oxidizing agent and the reducing agent, they are not strong. So we need a power source, which in this case, for electrolytic cell, we are using a DC power source. And then they always ask you, why do we need a DC power source? You are saying to ensure that the polarity remains the same, which means your anode and cathode must remain the same throughout. They don't have to swap anode, cathode. So we cannot use AC power source in terms of electrolytic cell. We must use direct current to maintain the polarity, so that the polarity remains the same, which means positive must remain positive, which is your anode, negative must remain negative, which is your cathode. So you are able to see that the difference between a galvanic and electrolytic cell. Now, already I talked about this, to say galvanic cell generate its own power, and then electrolytic cell requires a power source. So no electrolytic cell will take place without a power source. But when it comes to galvanic, it's self-sustaining, it's spontaneous, it's able to take place, because I showed you that we have a strong oxidizing agent reacting with a strong reducing agent, so we don't need a power source. But when it comes to electrolytic cell, we require a external power source, which is our DC power source, and then with that, then we are able to have a weak oxidizing agent reacting with a weak reducing agent. So in real sense, as long as you know how to identify the reducing agent and the oxidizing agent from table 4A and 4B, if you follow the arrows, you will always see which one is a weak oxidizing agent, which one is a weak reducing agent. And definitely when you see them, you know that the reaction there, it will be non-spontaneous. But when you see a reaction between a strong oxidizing agent and a strong reducing agent, you know the reaction will be spontaneous. Another way to show the spontaneity is by calculating of the EMF. Immediately when you calculate the EMF of the cell under standard conditions, If it's greater than 0, you know definitely that the reaction is spontaneous, and that must be galvanic cell. And then when the EMF of the cell is less than 0, definitely you know that is negative, then you know that it's non-spontaneous. When it's negative, it's non-spontaneous. When it's positive, it is spontaneous. So you can just calculate EMF, or you can look at the strength of the oxidizing agent and reducing agent. Definitely, they will show you that this must be a non-spontaneous reaction. But in the exam, when you show this reaction that is a spontaneous reaction, you calculate the EMF of the cell. And then when you get a positive answer, it is spontaneous. When you get a negative answer, it is non-spontaneous. And we are saying now, the anode, what is the polarity of the anode? Remember, under normal circumstances, we are saying under galvanic cell, the anode is negative. Remember, electrons are negative, and electrons must come from the negative one, which is the anode. Hence, we are saying under galvanic cell, which is a spontaneous process, the negative is the anode, the positive is the cathode. Correct. But what happens now when we're dealing with the galvanic cell? The anode is negative, the cathode is positive. But when we're dealing with the electrolytic cell, because now remember, it is now the electricity that is forcing the positive to be anode. Hence, we're saying don't panic. We're saying now the positive, now because of electricity that is forcing the positive, it's a forced reaction. The positive is forced to be the anode, and the negative is forced to be the cathode. Hence, now you will see that we have a positive anode and negative cathode under electrolytic cell, which I'm saying they are forced. Hence, we're saying it's non-spontaneous. It is that source of electricity that's ensuring that positive is anode and negative is cathode. I hope you appreciate now the similarities and the differences between galvanic and electrolytic cell. Sorry for that. And then as we move, we are able to say always, these tables, they are not, I always say this, they are not for decoration in terms of your question paper. You will find table 1 of physical constants for paper 2. Definitely you got to get used to this table. We have standard pressure. When you talk about standard reduction potential table, that is the standard pressure. So if you're talking about pressure, it's given. Standard pressure is 101.3 kilopascals, or you can write it like that as 1,013 times 10 to the power of 5, 50 to the power of 5 pascals. So if you say standard pressure, you can just copy it as it appears on table 1. Now you have your molar gas volume under standard conditions. Is your molar volume is 22.4, but I'm interested on the standard temperature to say now. Look at the standard temperature there. We are saying is 273, but for galvanic cell, the standard temperature is 298. So you can't copy from this table the standard temperature. It is 25 degrees Celsius. This is equivalent to 0 degrees Celsius. Hence, you must add the 25 there to get the 298 kelvins. So when you say standard temperature, is either you will say 298 kelvins or you will say 25 degrees Celsius. Always, when you talk about standard conditions, you always telling us how much. You don't just say temperature, pressure, or concentration. Now you say it is the standard temperature of 298 kelvins or 25 degrees Celsius. The charge of an electron, or the charge on an electron, is minus 1.6 times 10 to the power of minus 90. Definitely, when you start to ask you to calculate the current, definitely you will need this information. Avogadro's number, you have that information as well. So definitely you need this information from table 1. Now, when it comes to table 2, which is now on formula, we are saying if we are given the mass, definitely the mass is not for decoration. That is the formula in paper 2. So you are take, when you see mass, you go with it. You are saying mass, I must be able to calculate the number of moles when the mass is given. And you are able to move to say, okay, I can as well be given the because I know Avogadro's number. If I now know the number of moles, I can be asked to calculate the number of electrons or the number of particles. I must be able to substitute the number of moles and Avogadro's number. Then I can calculate the number of of particles or the number of electrons. In terms of paper 2, we're mostly talking about number of electrons. Now, as well, you know the C equals to N over V or the C equals to M over MV. The N equals to V over molar volume. Definitely you know that one as well. And then for this topic here, we're having the formulas now to calculate the EMF of the cell. And I want to emphasize that you see our E cell is not just E cell like that. There is that symbol that you see there at the top there is showing you that this is under standard conditions. And then I've emphasized that standard conditions simply means that we have your capital, you have your initial concentration of 1 mole per cubic decimeter. That's right, concentration in full. And then you have your temperature of 25 degrees Celsius. I've showed you that you can even say 298 kelvins is still correct. And then lastly, your pressure. I said pressure, you can take it exactly how it appears now on table 1, which is now a pressure of 101.3 kilopascals, or you can copy it as it appears on the table, which is your 1013 times 10 to the power of 5 pascals. So you copy it. That is a standard pressure. But now I'm saying when you say write down 2 conditions, you will definitely start with your concentration and temperature, because remember, pressure affects only gases. It's only when we have gas molecules in a reaction that we'll talk about pressure. So hence, I always say pressure, put it as number 3. But sometimes we are able to say, don't write the other 2. Don't include concentration, for example. Then you write the other 2 conditions. I hope we're together. And then that is our EMF. I've shown you that we are able to calculate the current as well. Remember, the current we are saying is Q over delta T. And then you are able to use this formula where N, the number of electrons, which you got here, the number of electrons, you are able to substitute there. And then you are able to know that charge of electron is that negative 1,6 times 10 to the power of minus 19. So you are able to utilize all these formulas. And then they are not for decorations, they are there to be utilized by you, and then ensure that you know how to apply them as we will be doing the questions. Now, I wanted to finish this by emphasizing this one to say, remember, in terms of galvanic cell, we said it's the strong oxidizing agent and strong reducing agent that are involved in the reaction. So immediately when you know the standard reduction potential for the strongest oxidizing agent and the stronger reducing agent, you are able to substitute them there, and your answer must be positive. Hence, we are saying it is spontaneous. And we are saying now E of a cell for cathode minus E of a cell for anode, and gain the potential for the reduction or oxidation. And we are saying, in the event you have forgotten the definition, you can say define oxidizing agent. You can come back to this table to say, okay, oxidizing agent is a substance that undergoes reduction. Reducing agent is a substance that undergoes oxidation. And then what is anode? Anode is the electrode where oxidation takes place. Cathode is the electrode where reduction takes place. You see, that's your memo there. That's your answers. And we are saying to check the spontaneity of the reaction. I would like to do this and indicate to yourself. To say, let's say, for example, you were given that zinc popular cell, the zinc copper cell, where you are having zinc forming your zinc 2 plus 2 electrons, and then that is negative 0.76, and then you had copper 2 plus gaining electrons to form copper, which was positive 0.34. You are able, for spontaneous reaction, remember the zinc reaction, you have reversed it. It's a reversed reaction. On the anode, we always reverse the reaction on the anode. So because we have reversed it, I can come next to this negative 0.76. I can come and put another negative there and add the 2 numbers there. The 2 numbers will give me 1,1 volts. And then I'm able to say, okay, let me write the overall cell reaction. What is on the left, you write on the left. What is on the right, you write on the left. So you are able to see that the first reaction, the one that is reversed, once you put a negative and you add them, you are able to see that that's another option of calculating the EMF of the cell. And if we were to deal with remember the reaction is zinc, the spontaneous reaction is zinc plus copper 2 plus, forming zinc 2 plus copper. But if you have a reaction where the reactants are zinc and copper 2 plus, which are the weak oxidizing agent and the weak reducing agent from the table, you are able to see that this, we are no longer reversing this one, we are reversing this one, hence we'll get a negative answer. And when the answer is negative, definitely we are talking electrolytic cell, a non-spontaneous process. I hope that helps you. As now we go straight to questions. After the table, we are saying table 4A and table 4B. And you always follow the arrow. Remember, on table 4A, on the left, we are always having oxidizing agent. On the right, we are always having reducing agents. And then just like that. So you are able to know that you always follow the arrow when you want the strong. If we say which one is the strongest oxidizing agent, you rush to the left, you follow the arrow because the arrow is showing you that the strongest is up there. On the reducing agent from table 4A, you follow the arrow. The same applies if you are using table 4B, which is the most popular table. And on table 4B, you can see that for the oxidizing agent, strength is downwards. For the reducing agent, the strength is upward. So it means that where do we find our reducing agent? Top right here. Top right, at the top right, we find our reducing agents on table 4B. Where do we find our strongest oxidizing agent? Bottom left. So oxidizing agents, they are on the left, and at the bottom of table 4B, you will find your strongest oxidizing agent. So that's how you utilize the table, and then you are able to answer questions. So we're going to apply that now, that knowledge, as we'll be dealing with questions. But before I do the questions, I just want to give you this exam question strategy to say, always know I'm dealing with what type of cell. If it's question 8, you are dealing with galvanic cells. Question 9, you are dealing with your electrolytic cell. In our case, we are saying the first thing that we must do, determine if it is galvanic or electrolytic. So check the question whether it's galvanic or electrolytic. Remember, how will I know, sir? You will definitely know if we have external power source, you know that is a non-spontaneous cell. And then if it's a spontaneous as well, look for things that will show that this is a spontaneous cell. So you must first say, is it galvanic or electrolytic? Number 2, you must label everything. Label everything must be labeled there. So clearly, you must say which one is the anode, which one is the cathode. You know electrons always from A to C. So you must know that electrons are moving from anode to cathode. So that is the third thing you look for, electron flow. And then you look for ion movement. Ion movement. Remember, the N ions or the negative ions always move to the anode. The positive ions, cation ions, always move to the cathode. So always look for that to say, okay, this is positive ion, it must go to the cathode. This is negative ion, it must go to the anode. And this happens for both galvanic and electrolytic cell. Anions to the anode, cations to the cathode all the time. That one always moves. So all that, and then you must be able to visualize the process. At least be able to see the two beakers having electrodes immersed. If it's a galvanic cell, see the salt bridge, see the electron flow in the external circuit, and see the electrons moving from anode to cathode. And then you must be able to write the half cells for those reactions. Always practice to oil rig and Leo Seger or Ga to remind you that oil rig to say oxidation is loss of electrons, and reduction is gaining of electrons. And the one I was talking about, loss of electron is oxidation, gaining of electrons is reduction. Always look for that. And definitely you are expected to calculate the standard potential, this EMF of the cell. And as you do that, the calculations, we are saying when your answer is negative, you know you are dealing with a non-spontaneous process. When your answer is positive, you are dealing with a spontaneous process. Okay? So I hope in terms of strategy and everything we are done, now we are centered around you, which is the questions. We'll start with the multiple choice questions. So we're given a standard galvanic cell, which is set up as shown below. So you are able to see that. And then they're saying which one of the following combination of the metal used as cathode and electron flow direction is correct. So let's look at this one. Definitely, wherever you are seated, you are having table 4a and table 4b. And definitely, if you go to the table now, I want you to have that skill to say, this serves as an address to say, where must I go in the table? What am I supposed to look for from the table in order for me to answer this question? So the information you are given here, very clear. It's saying, go and look for cadmium, CD, and look for cadmium 2 plus, CD 2 plus in the table. Go and look for them. And then go and look for silver and look for silver ions. So you go to table. When you're in table 4b, definitely if you look in that table, you will see where there is cadmium, there is CD 2 plus 2 electrons with 2 arrows, CD. In the table, you look for it, you got it. And then where there is silver ions, it's written like that, with an electron forming silver. So the table looks like that. And a science learner will always follow the arrow to say the arrow in 4b is downwards. So it's showing you the strongest oxidizing agent. And on the right hand side, you are having the arrow which is upward, which is showing you the strong reducing agent. So this arrow is simply saying to you, Ag plus is a stronger oxidizing agent than CD2 plus. Therefore, Ag plus will gain. You see, the stronger one is the one that will gain the electrons. Hence now, on the cathode side, Ag plus is the one that will gain electrons to form Ag. Why? Because Ag plus is a stronger oxidizing agent than CD2 plus. But when you go to the right hand side, you are finding the reducing agents. And we are saying CD or cadmium is a stronger oxidizing agent than Ag. Therefore, CD will lose electrons. You see, on the left we lose it, on the right we lose electrons, on the left we gain electrons. So they all have different potential. So on the left, we have the oxidizing agent or ability to gain electrons. And we are saying the arrow is showing you that Ag plus has more ability to gain electrons than CD2 plus. Hence now Ag plus will gain electrons. And where electrons are gained, so this arrow is showing you the strongest oxidizing agent and is showing you the reaction at the cathode. This is the reaction at the cathode as you follow the arrow downwards. Now, as we go up now, where we have reducing agent, we are saying cadmium, CD, is a stronger reducing agent than Ag, silver. Hence, we are saying CD, this one that is strong, is the one that will lose electrons. So you see that here, the reaction at the anode is at the top there of table 4b. The reaction at the cathode is at the bottom of table 4b. So you are able to see that, okay, CD is the anode, we lose electrons. So the reaction that is taking place at the anode is CD or cadmium losing electrons. On the cathode, we have Ag plus gaining electrons to form Ag. So our question is saying, between which one is in the cathode? You are able to come in and say, in the cathode, oh yes, we have silver. There, in the cathode, we have silver. Silver is in the cathode. This must be cathode. And then what is the electron? They always flow from anode. So if cathode is at the, if silver is at the cathode, then CD or cadmium is at the anode. And electrons, we said, they always flow from A to C, from anode to cathode. Definitely, you are seeing it, you are celebrating. You are saying, I can see the electrons are from CD to Ag. So you go to 2 marks there. You can even tell people that the paper was simple because this is really simple as long as you have the understanding. Now, let's move to the next question, which in this case was dilute hydrochloric acid react with magnesium solid at 25 degrees Celsius standard temperature according to the following reaction. Magnesium plus 2HCl forming MgCl2 plus hydrogen gas. Use oxidation numbers. Use oxidation numbers for each of the reactants and explain why this reaction is a redox. So they told you that you must use the oxidation numbers of your reactants. So our first reactants there is magnesium alone remember, alone. When free elements, according to oxidation numbers, we're saying free element has oxidation numbers of 0. So that will be the oxidation number of magnesium. Magnesium in a compound. Remember, chlorine is group 17, magnesium is group 2. Definitely group 2 have a charge of +2. So you know that, okay, for magnesium, it moved from 0 to +2. So already you can see that here, magnesium is moving to magnesium 2+, meaning that it has lost electrons. That is the first condition to say, wait, this one can be a redox because magnesium is losing electrons. Let's look now at hydrogen. Hydrogen was +1 here. Chlorine was -1. Remember, hydrogen is group 1 element. Chlorine is group 17, which is -1. So you are able to see that hydrogen is +1, and hydrogen together with itself, hydrogen, all our diatomic molecules, they have oxidation number of 0. So you can see that it's from +1 hydrogen to 0. So you can see that, okay, we're having 2H plus or hydrogen plus that is gaining electrons to form hydrogen gas. So definitely, this is definitely a redox reaction. But the question said, use oxidation number to increase. So you can show that, okay, magnesium becomes now, loses electrons to become magnesium 2+. Hydrogen ion gains electrons to become hydrogen gas. And you are able now to answer that question and say the oxidation number of hydrogen changes from +1 to 0. That's what I've said, from +1 to 0. And oxidation number of magnesium changes from 0 to +2. Then you got your answers. You are smiling, you are moving, you got your answers. You can even show them as I've shown them that side, and you are showing that magnesium increase in oxidation number, which is called oxidation, and H+, it decreases in oxidation number, which is now we have it formed H2, not H2O. It formed H2. So you are able to see that the oxidation numbers of H+ decreased to 0. The oxidation number of Mg increased from 0 to +2. And then this is a redox reaction indeed. Now, write down the formula of the oxidizing agent. The oxidizing agent. So you are able now, it's asking you to say, okay, if I go to the table, where do I get magnesium? Where did I get H+? Definitely, you will see that magnesium is on the right-hand side of table 4b. And then you are able to check now, where do I get the H+? H+ is on the left. Remember what I said? During a galvanic cell, we have a reaction between strong oxidizing agent and strong reducing agent. Definitely, where magnesium is, reducing agent. Where H+ is, oxidizing agent. So you can see that we have a reducing agent reacting with the oxidizing agent. And then the question said, write down the formula of the oxidizing agent. And then with no fear, you can write HCl or you can write H+. We'll give you your mark there and you are cruising nicely. Now, if we continue that question, explain this observation by referring to the relative strengths of the reducing agent. Already I've told you that, okay, if we're talking about reducing agent, we'll talk about magnesium. If we're talking about, they said we must talk about reducing agent. Definitely, on the reducing agents, you must talk about only reducing agent. And if you go to that table, you will see that the table is given as Mg2+ plus 2 electrons from table 4b, forming Mg. And you have 2H+ plus 2 electrons forming H2. So you are able to see that, okay, fine. The arrow, this side is downward and is a return oxidizing agent, which means 2H+ is a stronger H+ is a stronger oxidizing agent than Mg2+. Therefore, H+ will gain electrons to form H2. But the question said, talk about reducing agent. So you are limited here. You cannot talk about oxidizing agent. They're saying, talk about the right-hand side of your table 4b. Now, you are simply saying, okay, reducing agent, they increase as we go up. So, which means my magnesium is a stronger reducing agent than H2. Therefore, magnesium will be oxidized to magnesium 2+. So you are able to respond to that question by looking at the table. You can talk about a weaker one or a stronger one. I always choose to talk about the stronger reducing and oxidizing agent. Okay, in terms of this question, it was based on copper, as they brought in the copper inside to say, explain this observation by referring to the strength of reducing agent, and definitely copper is a weaker reducing agent than hydrogen and will not be reduced. Or you can talk in terms of that because the question was about reducing agents. Now, the other question they said, will dilute nitric acid react with copper? Choose from yes or no and explain the answer in terms of relative strength of oxidizing agent. You see this thing of relative strength of oxidizing and reducing agent, definitely you will need to have that information and you are able to say yes. Why is it a yes? Because your nitric acid is a stronger oxidizing agent than copper 2+. So remember, it must be, you must have a stronger oxidizing agent and a stronger reducing agent so that the reaction takes place, and then you are able to answer that question 2.1.4. Now let's look at activity 3. This one. Now you can see there are different ways of answering questions, of asking questions. In all the questions that we have been doing in terms of structured questions, there is no question where we're given two beakers. All our questions you see now, this one, we're given the overall cell reaction. Overall cell reaction. On the other one, we're given the way we're supposed to look at the oxidation numbers. So you can see that this question is always, there are different ways of asking the questions, and we intentionally included different types of questions so that we are able to move together with yourselves. So look at this one. You are able to look at it and say and have appreciation. So okay. Remember, said on the reactants under galvanic cell, we have a stronger oxidizing agent and a stronger reducing agent. Now, they're saying the following balanced chemical equation represent a reaction when a galvanic cell is operating under standard conditions. The initial reading on the voltmeter is 0.14. So we're given the EMF of the cell. We're given the EMF of the cell is 0.14. Now the question is, write down two standard conditions under which it operates. You see, with this one, it's better. You are asked for two. You can write any two because we have chlorine gas there. So even pressure will be accepted. But I will always encourage you to always start by writing initial concentration of 1 mole per cubic decimeter and temperature of 25 degrees Celsius. Then you can write pressure of 1 atm or a pressure of 101.3 kilopascals, or you copy it from the table as 1013 times 10 to the power of 5 pascals, as is written on the table 1, as I showed you. So you are able to write the two standard conditions and you are able to get your 2 marks. Remember, all these are taken from previous questions with the focus mostly on previous prelim exam questions, as you have the prelim exams in your mind to say, think about the different ways which the question comes. Because immediately when the question is given like that, you know that we must be having a stronger oxidizing agent and a stronger reducing agent. And all of those, they are forming the products there that we're having. So you are able to see, you have written the two standard conditions that were asked of you, and then you were able to say initial concentration is 1 mole per cubic decimeter, temperature is 298 kelvins. Always safe to write these two because pressure is conditional, that only when we have gases. For this cell, you are asked now another question to say, for this cell, write down the name or formula of the electrolyte that can be used in the salt bridge. So now you know your salt bridge, there must be a salt. And remember that salt, we are saying it has ions. So that you have N ions that will move to the anode, cations that will move to the cathode. And then you are able to indicate that one salt that we can use is our potassium nitrate. The question said you can write the name or the formula. And then you are able to answer that question to say we can use potassium nitrate, we can use KNO3, which is potassium nitrate. And remember, the function of the salt is that definitely it has a positive ion, which is your metal ion there, K plus, and it has your NO3 minus. And we're saying the cation, the positive one, it will always move. This one will always move to the cathode. Always, whether you are talking which cell, galvanic or electrolytic, the cation moves to the cathode, the anion moves to the anode. Please don't forget that. I'm always emphasizing so that we don't lose marks. We are able to move. Now, in this one, they are saying which one is the reducing agent? Which one is the reducing agent? Now, you can as well look at the oxidation numbers. They will tell you, because you can see chlorine there is -1, Mara Cl2. Remember diatomic molecules, we said their oxidation number is 0. So you can see that from -1 to 0, you can see that chlorine, the oxidation number has increased. And when oxidation number increases, it shows that electrons were lost. When you lose electrons, you become positive, or your oxidation number increases. So you can see that what is happening really here is that chlorine minus 2Cl minus is losing electrons to form Cl2. So you can be able to see that, okay, in real sense, we're having 2Cl minus losing electrons to form Cl2 plus 2 electrons. So you can see the 2Cl, the 6 there is for balancing, because we're having Au, which is gold 3 plus. So you are able to see that, okay, at the anode, we have 2Cl minus losing electrons to form Cl2 plus 2 electrons. Then you are able to look at it that way. We said loss of electrons. We said loss of electron is oxidation, and that's where we find our reducing agent. Reducing agent is Cl minus. So you are able to see your reducing agent there to say, okay, Cl minus is our reducing agent. Why? Because it's losing electrons. Because we said a reducing agent is a substance that loses electrons. And if you can see, we have Cl minus becoming Cl2 this side. Then it has increased from -1 to 0, which is oxidation, which is loss of electrons. So you are able to answer that question and say chlorine minus is our reducing agent. Remember, the reducing agent and oxidizing agent are always the reactants of a galvanic cell. Now, with no wasting of time, we're able to move now to say, remember, we're told that the EMF of the cell is 0.14 volts. Now, the question is, for this reaction, write down the cell notation. I'm happy. This type of questions, when you practice them, they are preparing you for exams, because they are not your obvious type of cells where you have the 2 picars and the electrons. Now you are only given this, but we're saying from this information, you can be able to write the cell notation. And then for you to be able to write the cell notation, we are saying now, remember cell notation, we said is A, B, C. Always don't forget. We always start with the anode. So you can see that, okay, the one that is, we already have shown you that we have Cl minus becoming Cl0 there. The oxidation numbers have shown us that Cl minus is becoming 0. So that is oxidation, because it has increased in oxidation number. So you can see that at the anode, we're having this Cl minus. And this Cl minus is becoming Cl2. Hey, look at the goodness of science. So you are starting from there. You are saying Cl minus is becoming Cl2. Now, we have the salt bridge. At the cathode, we have Au3 plus, which is 3 plus. Remember, when an element is alone, the oxidation number is 0. So you have gold 3 plus becoming gold 0. So you are able to see there that Au is 3 plus, is becoming 0. Definitely, it means this is the reaction at the cathode, which is gaining of electrons. Au 3 plus is becoming Au. Now, you see that on the gold side, we have the solid, but on the chlorine side, we have a gas. Remember, Cl2 is a gas, and chlorine minus is aqueous solution. So, for us, we always need an electrode that is solid, that is a good conductor of electricity. So definitely we're going to look for platinum, to say platinum, come and be our electrode here, to be able, because platinum is a good conductor of electricity. So always when we're writing cell notation, we must have a solid on the anode side. We start with the solid on the anode side, we end with the solid on the cathode side. So you can see that we have platinum now. Platinum, we use it when we don't have a solid. We'll definitely use platinum because it's a good metallic conductor of electricity. So we use that. So we'll have platinum there, and then this side we had gold, which is solid, then it's fine. We leave it like that. So you are able now to answer that question, and you write the cell notation, which is your platinum. Remember these lines, we said they show different phases. We call them the phase boundaries. So you can see that our platinum is solid and our Cl minus is aqueous. Our Cl2 is gas. Hence we're saying we will use solid lines always because they have different phases. But if they have same phase, we'll use comma instead of solid lines, because the solid lines shows that the platinum is in different phase with chlorine minus, which is in different phase with Cl2. Hence we're using the solid lines there. But if the phases are the same, you would use a comma. So in this case, it's those ones. The same here on the cathode side, we have gold 3 plus forming gold. So you can see that if you go to the table of standard reduction potential and look for gold, you will look and you will mine for it and look for it, and then you would find that you are not getting it. Hence, when this question comes, it came now with 0.14, which will definitely help you in terms of the calculation or in terms of finding the standard reduction potential for gold, and which can be the question, because chlorine already, we know chlorine on the table, but now on the table we have no gold, but we have the EMF. So remember, when you are given two, remember our formula for EMF, we're saying EMF of a cell is E cathode minus E anode. So already we know the EMF is 0.14, and then we have seen that chlorine is the one that is losing electrons to become Cl2. So you can see that chlorine is on the anode. So definitely we're going to substitute the value or the standard reduction potential for the chlorine, and then we're able to calculate the one for the cathode, which is definitely will be the question that comes thereafter. To say, what is the standard reduction potential of gold? Definitely you are laughing alone, you are saying this is nothing, I'm collecting these marks, and then you are able to calculate the EMF of the cell by first writing the formula. Copy the formula as it appears in the data sheet, and then after copying the formula you will get 1 mark, and then substitute your mark there, will give you the mark for the 0.14. That one I will take it out, will give you the mark for the 1.36, and then you'll get is the mark for the formula for the substitution, correct substitution of 0.14, correct substitution of 1.36 there for chlorine, and then you are able to calculate the E reduction. Remember, when transpose, you take minus, come this side, it becomes positive. Definitely you get E, the standard reduction potential of gold, as 1.5 volts. So you are able to get your answer, and you got your question there, and you are celebrating. I hope this has helped you to see different types of questions and how to approach them. And then let's move to electrolytic cell now as well, to say now the same can be done now when we're dealing with electrolytic cell. To say we're given here an electrolytic cell which is set up to electroplate an iron rod with nickel. Remember, your focus is with what? What are we with nickel? Which means your focus is on nickel. Leave iron alone. Iron rod is they're just telling us the type of the rod. It's made up of iron. It can be any rod. It doesn't matter, as long as we know that we are electroplating with nickel. What matters to you is the nickel. Then the rod must be electroplated. Now, you know we don't panic in this question. The positive one, this one is positive, is our anode. We know our anode is positive under electrolytic. Positive is anode, negative is cathode. So we know we have the negative one. This one is our cathode here. And then in the cathode, that's where the object to be plated is always at the cathode. The object to be plated is always at the cathode. Our metal is always at the anode. The width part is the anode. So our anode is nickel. So this is clear. We have nickel here as our electrode here. It's nickel. On the iron rod, this is our iron rod. But me, I won't even call it iron rod. I'll just call it rod, so that you don't get confused. It is just a rod that needs to be electroplated with nickel. Definitely on the anode, we lose electrons. So you definitely know that here from the anode side, we have nickel. Definitely nickel must lose electrons. Nickel loses electrons at the anode. What happens at the cathode? Definitely at the cathode, you have the reverse reaction, which is nickel 2 plus gaining electrons. So these ones always, remember when I started, I talked about a question like this one, and I said during electroplating and during purification of a metal, the concentration of the electrolyte here, this is our electrolyte, which is nickel 2 plus, this concentration remains constant. Why? Because the rate of oxidation is equal to the rate of reduction. Sorry for that. So now you are able now to see that, okay, this is oxidation, lots of electrons, this is reduction. And then with no wasting of time, we can go to questions now. We know everything that is happening. We have analyzed the question. Now they are saying, consider the following statement. They are saying the iron rod is negative electrode. Oh, negative is cathode. Iron rod, yes, correct. You see now, analyzing a question helps you now to, when you go to the answers, you are able to see them and you don't waste much time. The metal ions, which is nickel 2 plus, in the solution undergo reduction. Yes, nickel 2 plus, which is the metal ions, undergo reduction. Correct. Very correct, this one. The anode is pure nickel. Nickel is in the anode. Positive one is nickel. We talked about it. Correct. So you are able to see Roman figure 1, 2, 3. All of them are correct. Therefore, you're going to say, I need which of the above is true. You're saying 1, 2, 3. They are all correct. Definitely D is our correct answer. And you are sure because you did the question, you have analyzed it, you have understood it. I hope this helps you. Now, let's go to activity 2. A strip, I think this is our final exam 2024, question 9. A strip of silver is added to 1 mole per cubic decimeter solution of lead nitrate, PbNO3. Remember, the nitrate is a -1. We have 2 of them. So you can see that our lead is Pb2 plus. In our solution here, we have Pb2 plus. Always go to the electrolyte and find the ions to say, okay, the ions we have Pb2 plus and NO3 minus. And NO3 minus is just a spectator ions that is watching the game, but Pb2 plus is our electrolyte. That's the electrolyte of choice. So we are putting silver strip inside lead 2 plus, Pb2 plus solution. That's what we're having. So we're having Ag is silver, this one, that is being put inside lead 2 plus solution. Lead nitrate, it means lead 2 plus, our electrolyte. Remember what is electrolyte? We said this is a substance of which the aqueous solution contains ions. So what are the ions? Pb2 plus and NO3 minus. And I'm saying we are more focused on Pb2 plus because we are having Ag and Pb2 plus in our question. Now we've analyzed the question. We can go consider the reaction below. So they told you that the reaction is this one. In our reaction, we have Ag solid and Pb2 plus reacting to form Ag solid, Ag plus, the plus at the top, solid forming Pb. So you can see that is our reaction that is taking place. Now, by means of a calculation, determine whether this reaction is spontaneous or non-spontaneous. Remember, this question was asked 2024 question 9. which is electrolytic cell. So the learner already has in his mind that in question 9, we deal about non-spontaneous processes, which must be negative, which means now you are going to look at silver and Pb2 plus, whether they are strong oxidizing agent and strong reducing agent respectively. So you look at them and say, okay, if I go to the table, will I find Ag as a strong reducing agent? Will I find Pb2 plus as a strong reducing agent? And definitely, when you check them, you will see that we're having silver as a weaker oxidizing agent. Remember, the strong oxidizing agent, they have, it's a weaker reducing agent, and then Pb2 plus is a weaker oxidizing agent. So you can see that if the reaction was about Ag plus and Pb, it will have been a spontaneous reaction. But these two, weak reducing agent and weak oxidizing agent, go to the table, you will see that, and then it tells you that this must be an electrolytic process. It must be non-spontaneous, meaning that when I do my calculation, it must give me a negative answer. And then you are able to do your calculations to say, okay, let's check. According to this, silver is undergoing oxidation, which means I can write Ag is becoming Ag plus an electron. Pb2 plus is gaining 2 electrons to become Pb. That is what we are given. And you know loss of electron is at the anode. Gaining of electrons is at the cathode. So at the anode, the reaction is called oxidation. At the cathode, the reaction is called reduction. So you can see we chose the formula E reduction. Reduction is where we're having our Pb there, and then you are having that. So you're able to see that, okay, on the standard reduction potential from the table, standard reduction potential for lead is negative 0.13. You can check it. And then minus, this minus sign. For silver, the standard reduction potential is 0.8. And if you use your calculator, negative 0.13 minus 0.80, definitely you are going to get negative 0.93 volts. So you are able to see that I know this one must be a non-spontaneous process. But we are saying that is not the only way of calculating EMF of the cell. You can, according to the given information, as I've done for you here, you can write the two half fractions. For the lead is Pb2 plus 2 electrons forming Pb. For the silver is losing electrons. And because the electrons are not balanced, you multiply Ag by 2. Everything is multiplied by 2 there, so that we have that. And then you go to the table, you will find that the standard reduction potential for lead is negative 0.13, but the standard reduction potential for silver is 0.80. But the one that is losing electron, the anode, we always reverse it, remember, the way it's written on the table for B. It was reversed, that's why we're putting a negative sign, because we reversed it. We're putting a negative sign there, and if we say minus 0.13 minus 0.80, you'll get negative 0.93 volts. And then you are able now to get your 3 marks as well. So we're saying there are two options as we mark this EMF calculation. Option number 1 is the simplest one, the one that we find more simpler, but you can have your own preference. And then this is option number 1. You can just use the formula. You can say E cathode minus E anode. You can say E reduction minus E oxidation, E oxidizing agent minus E reducing agent. So you choose the formula, or you can write the two fractions. You write the overall net cell, and then on the anode side, you must put a negative sign because you are reversing the negative one. And definitely, you will still be able to calculate the EMF of the cell. So if I was you, for enjoying the subject, continue to use both methods as you practice and appreciate that you can do all that. And then the reaction is non-spontaneous. Remember, we said when the EMF of the cell is negative, it shows you that the reaction is non-spontaneous, which means energy must be added. We need DC power source to be able to have this equation. So that was question 9.1 for question 9 in 2024 final exam. Now, as we continue with the question, we go to now to question 9.2.1, which in this case, we said 2.2.1 for this activity. We are saying now define an electrolyte. You can't go to the exam room without knowing these definitions. You are simply saying an electrolyte, you know. You are saying, okay, this is a substance of which its aqueous solution contains ions. Or you can say a substance, when dissolved in water, give a solution that conducts electricity. So you are able to do all that, and then you are able to get your 2 marks for defining an electrolyte as a substance of which the aqueous solution contains ions, or a substance that dissolves in water to give a solution that conducts electricity. So it's your preference, whichever you find easy. But this first one, I find it very easy because you are simply saying aqueous solution contains ions, because here you're just saying a substance. So it's a substance of which the aqueous solution. So you're simply saying the aqueous solution contains ions. So it's even aqueous is even in brackets there to show that you can say solution that contains ions. So remember, it's up to you, whichever you find much easier, enjoy. But those two are 2 definitions of an electrolyte from the exam guideline, and whichever you write will definitely mark it correct. Write down the predominant. I'm happy now that this question was asked this way, to say predominant oxidation. So they are saying there are other oxidation that might need to take place, oxidation or friction, but this one is the predominant. It's the one that will definitely take place at the anode. So we are appreciating that there is not only one reaction that can take place. Remember, oxidation, we said an ox, so it happens at the anode, and we said positive is the anode here. And then we said positive is the anode, Positive is the anode, so the positive one is the anode. The negative one is the cathode. So you know, this is our cathode, this is our anode. That one we know for a fact. And then we have now in our solution sodium, but we said this sodium chloride is sodium plus, chlorine minus, but we have water. And remember, water is made up of H plus and OH minus. So don't forget that. Water is H plus and OH minus. So we're simply saying that we have sodium is positive, definitely to be attracted to the cathode side. OH minus is, H plus is positive, it will be attracted that side. And then that is on the anode side. On the cathode side, you are having Cl minus that goes that side, you are having OH minus. See, those are the options that the ions that will be attracted to the positive one. And then when they say predominant, we know that always when we have chlorine, we have Cl minus under electrolysis. We are saying that chlorine gas will always be formed at the anode. Definitely, the anode, we are saying that there must be 2 Cl minus. When the Cl minus moves this side, it loses electrons, and then it leaves out as a gas. Cl2 is given off. Chlorine gas is produced. Chloride ion, remember, you don't call them chlorine ion, you call them chloride ions. The chloride ions are attracted or move towards the positive, which is our anode, and then when they are there, they lose electrons and Cl2 gas is formed, and then that is 2 marks. Hence they said predominant. They are saying there is any other reaction that might take place, but this is the predominant one. I hope you get that. Write down the names or formula of the products formed at Q. Now they want you to write now the product that will be formed at Q. So electrode Q, and then you are able to look at that to say, okay, at Q we have sodium plus, we have H plus. H plus is gaining electrons, definitely to form hydrogen, but we have sodium plus, it will react with the OH minus to form sodium hydroxide. So you can write hydroxide ions, you can write hydrogen gas at Q as the product formed there. Now, explain the answer to question 2.2.3 referring to the relative. You see, this question is not going anywhere. The question that is saying referring to the relative strength of oxidizing agent. So they are simply saying that you are on the left of the table where we find oxidizing agents. So now explain this answer that you wrote there in terms of that, and then you're able to say, okay, On the left, we are having water. Remember, when you look at the table, you will find, if I write at this space, you will find that we are having water, which is 2H2O plus 2 electrons, forming H2 plus 2OH minus on the table. And then we are having as well sodium plus an electron, forming sodium. That is on table 4A. To start with that one. And then where in 4A, you will see that the arrow is pointing that side to say the strongest oxidizing agent is water. So hence we are saying water is a stronger oxidizing agent than sodium plus. You see, therefore water will be reduced to that. Or that is table 4A. If you look at table 4B, you will see that it will start with sodium plus an electron, forming sodium, and then water plus 2 electrons, forming water, forming hydrogen gas plus 2H minus, and the arrow is downwards. And then they say talk about oxidizing agent. So the arrow is showing you which one is stronger. You're saying water is a stronger oxidizing agent than sodium plus. Therefore, water will gain electrons. Water will be reduced. Water will be reduced. So you are able to answer that question and be able to get all the 13 marks that were asked under question 9 in 2024. So I hope all this information will help yourself. Now, the question on the graph to say define the term electrolyte. Remember, we have done this question already. We've indicated that an electrolyte is a substance of which the aqueous solution contains ions. Or we said when a substance is dissolved in water, it will give a solution that conducts electricity. So we know what an electrolyte is. Which electrode, M or N, represent the ion bar. So in this case, they're saying, okay, ion bar. So this is electroplating. We're having to electroplate ion bar with copper. And when you look at the graph, we're having the mass of electrode M that has increased from 12,52 to 17,85. So definitely you can see that M is increasing in mass, which shows that it is definitely at the cathode. And at the cathode, that's where we must have now our ion bar, because it's increasing in mass, because it's being plated. It's being plated definitely with copper. So definitely you know that there it must be M must be our electrode. It must be our ion bar. Our ion bar is that one, and then write down a reaction to show that definitely at the ion bar there we have copper 2 plus gaining electrons to form copper. It is observed that the concentration of the electrolyte remains constant. That question I've been talking about to say the concentration of the electrolyte remains constant. During the electrolytic process, I said during electroplating and during purification of a metal, concentration of the electrolyte remain constant because the rate of oxidation is equal to the rate of reduction. So we are saying the reason for that is that copper is being plated on the metal M. Now, the next question, write down the type of electrochemical cell above. Definitely you can see that is an electrolytic cell. The reason being that it has a power source. Now they're saying this graph shows the change in mass of electrodes while the cell is in operation. So you can see we're having increase in mass and decrease in mass. Then they're saying define reducing agent. Remember, we said it's a substance. It's a substance that undergoes oxidation, or the substance that loses electrons. So you're able to say a substance which loses electrons is our reducing agent. Write down the half reaction that takes place at the electrode A, and then you can be able to see that this is a positive. Positive, we said, is anode, and at the anode we lose electrons definitely. So copper must be losing electrons at the anode. At the cathode, because the process was purification, at the cathode will be the reverse of that reaction. And then electrodes A and B are now replaced by graphite. They are saying instead of having copper there, we're having carbon. Graphite is carbon. We're having carbon and carbon. now this process now would be electrolysis of copper chloride, and then they are saying at which electrode A or B will chlorine gas be formed. Remember we said chlorine gas is formed at the anode, and definitely the anode, positive anode, so the anode is that one, so definitely at A, that's where we'll have our anode. Why? Because 2Cl minus will be attracted to the positive. Remember this is positive, and then the 2Cl minus from the solution will be attracted to that one, and definitely chlorine gas will be formed. So we're saying Cl minus is A because Cl minus move to the positive electrode where they are oxidized to Cl2. So you're able to do that, and then I just do the summary to say always identify the anode and the cathode clearly. Always remember oil rig. We are saying oxidation is loss and reduction is gain. Be careful with signs of electrodes. Remember for galvanic cell, we said anode is negative and cathode is positive. When you go to electrolytic cell, we say don't panic. Positive becomes anode, negative is now cathode. And always use correct cell notation. Remember we said A, B, C. You will write the anode, the salt bridge, and then the cathode. Galvanic cell, we said the reactants are always strong oxidizing agent and strong reducing agent. Whereas for electrolytic cell, the reactants are always weak oxidizing agent and weak reducing agent. Hence, electricity is needed for electrolytic cell. And we are saying electrolytic cell is a non-spontaneous process. We just want to say, just in time, we'll meet on the 11th of September 2025 from 2:30 to 4 o'clock, where we'll be doing paper 1 revision. We'll be doing paper 1 revision, the entire paper 1 as we prepare for your exam, your prelim exams. And then we're saying always, as we do, anyone who has made a mistake has never tried anything new. Thank you very much.